Hey, Geo, I don't like how those clouds look. I've never really been that fond of rain. Water and computers just don't mix.
Right, but almost every plant and animal on the Earth needs water in order to survive.
Well, that might be true, but computers still don't have to like it.
No, but it never hurts to know more about it. Why don't we connect our databanks and explore a process called the water cycle? By the time we're through, you might even appreciate water for the amazing, powerful resource it is. Iggy, water is very important to life on Earth. Plants take in water through their roots, while animals need to drink it in order to survive.
With all those animals and plants needing water, I guess there's a lot of it on the Earth, right?
There sure is. Almost 3/4 of the Earth's surface is covered by water.
Is that why the Earth looks so blue from outer space?
Exactly, Iggy. Almost all of the Earth's water is the salt water that's contained in the ocean. That's fine for the animals that live there, but ocean water is too salty for people to drink.
So how much fresh water is there?
Actually, Iggy, I'm going to need a little help on that. My files aren't complete.
Then let's call up the Kids Into Doing Science Club for more information.
Hello, Kids Into Doing Science. This is Sarah. How may I help you?
Hello, this is Geo and Iggy. Would you have any good demonstrations to show how much of the Earth's water is fresh water?
Sure, just let me get the files. Okay, here's an easy way to picture all the Earth's water. Imagine you have 100 large cups, and each cup is filled with water. If these 100 cups held all the water on Earth, only about 3 cups would hold fresh water. All the rest would be salt water. Let's go further. Take your 3 cups of fresh water and use all the water in them to fill 10 smaller cups. Now freeze 8 of the smaller cups of water, because that's how much of the Earth's fresh water is frozen as ice and cannot be used by plants and animals.
Hey, there's not much water left.
Now, take a small eyedropper and fill it from one of the last 2 small cups of water. The water in the eyedropper represents the usable fresh water that's above the surface of the Earth, in lakes, streams, ponds, and rivers. The rest is underground.
But what happens when a little bit of water gets used up?
It won't, and that's the most marvelous thing about water. The Earth has about the same amount of water now as it did millions of years ago. It just keeps getting recycled over and over again.
Thanks for the help.
You're welcome. Bye.
Bye! When it comes to recycling water, no people are necessary. You'll understand better as we take a look at the 3 stages of what is known as the water cycle. It all begins with evaporation.
Evaporation?
Evaporation. Here's an example. When this swimmer gets out of the pool, his body is covered with liquid water. But if it's a warm, sunny day, soon the liquid water dries off his skin. That's evaporation. Evaporation occurs when liquid water turns into water vapor, and it is constantly happening around the world. Wherever water and air touch, some water is always moving off into the air as water vapor. Evaporation can happen when things are cold, but it happens much faster when things are warm. Do you know what warms things and speeds up evaporation?
That would be the sun.
Yes, the energy from the sun warms the water and speeds up evaporation. The sun provides the energy to start the water cycle through evaporation.
Wow!
Of course, water is evaporating everywhere, from oceans, lakes, streams, plants, and even out of the soil.
Geo, something's been bothering me. Since people can't drink salt water, all that salt water in the ocean is pretty much wasted until it evaporates, right?
Well, Iggy, the ocean provides many wonderful benefits to people and other living things. Oceans are the biggest source of evaporation on Earth and are alive with plants and animals that can be sources of food. For many thousands of years, ships have sailed over the ocean carrying people and things all over the world. Currents in the ocean help cool off the air over hot parts of the world and help warm up the air over colder parts of the world. In addition, ocean waves constantly reshape the coastlines too.
Gee, I had no idea how special the ocean really was. Okay, Geo, let me see if I've got all of this right in my memory banks. We have a whole lot of water on the Earth, and most of it is salt water in the ocean. And we've got the same water on Earth that has always been here. It just gets recycled through a process we call the water cycle, which begins when the sun evaporates the water, turning it into water vapor. It's all downloaded into my memory banks. So what else happens in the water cycle?
Condensation, Iggy. Condensation is how the water vapor, or gas, gets turned back into liquid water. Let me ask you a question. If it takes the heat from the sun to turn water into vapor, what might be a good way to turn water vapor back into liquid water?
You turn off the sun, at night?
Good thinking. But condensation can take place during the day or at night. Basically, anytime the air containing the water vapor cools. Cold air can't hold as much water vapor as warm air. As the air first begins to cool, the extra water vapor starts to form teeny tiny drops of liquid water. That's what clouds are made of. Wherever the air cools, you get condensation. You can see this happening on the outside of a cold drinking glass on a hot day.
So we've got evaporation and condensation, the liquid water turning to water vapor and back again. Is that the whole water cycle?
Not quite. Iggy, you've seen that tiny water droplets can remain in the air. But what do you think would happen if these droplets got a lot bigger?
Well, I guess the water would fall.
Bingo! The final step in the water cycle is precipitation. This is how the water droplets get from the air back down to the earth again. When the droplets get too large and too heavy to stay in the air, they fall as rain. If things are cold, the precipitation might be snow, sleet, or hail. But it is always fresh water because only pure water vapor was in the air to begin with. Let's watch this process in action.
Today, we're going to demonstrate how the water cycle works by creating our own mini water cycle in a bowl. You'll need a large, clear glass bowl, a small bowl, a pitcher of clean water, salt, a spoon, plastic wrap, a ruler, and a small marble. First, slowly pour the water into the big bowl until it's about 1 centimeter deep. Now, add a few dashes of salt into the water. Stir the water with your spoon until all the salt grains have disappeared. This means that the salt grains have dissolved into the water. The water is now salt water. Taste it. It's salty, right? Next, place the small bowl in the center of the large bowl. Then cover the large bowl with plastic wrap. Be sure the wrap clings to the sides of the bowl. Gently set your marble on the center of the plastic wrap. Make sure that the marble is directly over the small bowl. This should cause the wrap to sag just a little right over the small bowl. You'll see why this is important in a moment. Carefully move your bowl to a warm, sunny spot for a few hours.
Oh, I see what they're doing now. The salt water in the bowl represents the ocean and the sunshine will evaporate the water.
Exactly!
After a few hours, check your bowl. You should see that some changes have occurred. First, there will probably be water droplets clinging to the bottom of the plastic and sides of the bowl. Second, there should be water in the small bowl that wasn't there before. Remove the marble and plastic wrap and taste the water in the small bowl. It should not be salty. It's fresh water.
And how did this happen?
Sunlight heated the water inside the bowl, causing some of the water to evaporate and form water vapor. This is similar to the way ocean water evaporates when heated by the sun. When the water vapor touched the plastic and sides of the bowl, it cooled and condensed. The drops that condensed on the underside of the plastic wrap slid down the wrap to its lowest point, under the marble. When enough water collected there, it became too heavy to cling to the wrap, and fresh water dripped into the small bowl.
Very cool! Evaporation, condensation, and precipitation. The water cycle all in one bowl. The sun warms water and evaporates it, turning it from a liquid to a gas called water vapor. The water vapor cools and condenses into droplets, and the droplets become too heavy and fall back to the earth as precipitation.
Precipitation is the last stage in the water cycle, but all the water that falls as precipitation doesn't evaporate again right away. Iggy, remember how the Earth's fresh water might be pictured in 10 little cups and 8 of them were frozen? Much of the Earth's fresh water is frozen into ice. In some very cold, snow-covered places, like at the Earth's north and south poles, the ice caps never melt. The ice piles up year after year and can't be used by plants or animals.
Okay, so where is all the Earth's usable fresh water?
Part of it is on the surface of the land. Remember that eyedropper full of fresh water? Well, there are different places this water can go on the Earth's surface. When rain falls on land, or when snow, sleet, and hail melt, much of the water soaks into the soil. But once the soil holds all the water it can, the rest of the water begins to run off. It collects into little creeks that join to form streams. And streams can join to form powerful rivers. The water in rivers and streams moves towards the ocean. Along the way, however, the fresh water in rivers and streams is used by all sorts of animals and people. Often, small towns and large cities are built along streams and rivers. The water in them gives people drinking water for their homes and water for their businesses. Farmers often use rivers and streams as a source of water so that their crops can grow.
So is all the fresh water on the Earth's surface flowing in rivers and streams?
No, not at all. Sometimes the precipitation that falls on land collects and forms ponds and lakes. Some lakes are huge. The Great Lakes in North America are hundreds of kilometers long and wide.
Water in rivers and streams, ponds and lakes. Got it. Saved to memory.
Of course, people also use dams to trap river water in artificial lakes called reservoirs. Reservoirs are great sources of fresh water, and water spilling out of dams is often used to provide energy.
Geo, you said that most of the fresh water that falls as precipitation soaks into the ground.
You bet! And that's why water under the ground, called groundwater, is one of the most important sources of fresh water for people, especially in areas that don't get a lot of precipitation.
But how does it get into the ground?
When precipitation falls on the ground, a lot of it remains in the soil. The soil soaks it up like a sponge, but a lot of it keeps moving. It sinks slowly down through the ground as far as it can go.
What do you mean, as far as it can go? What stops it?
It stops when it meets a layer of rock it can't pass through.
Sort of like an underground dam.
That's right, Iggy. This groundwater then fills up, forming an underground reservoir. People sink wells into these underground reservoirs to get this water. But it can also leak out of the ground through natural springs. As an underground reservoir fills, the level it fills to is called the water table. The water table can move up or down as the underground reservoir gets more water or loses water. If the water table gets too low, springs dry up and wells stop pumping water.
So underground reservoirs can run out of groundwater.
Yes, they can. And when they do, they often leave behind some interesting formations. Let's take a look at one.
Have you ever visited an underground cavern? All over the world, caverns such as Carlsbad in the United States and Xelha in Mexico's Yucatan Peninsula allow visitors to make their way through underground chambers that have been naturally created over millions of years. But have you ever wondered how these caves were created? Believe it or not, all of these interesting formations were created by a little water. When pure water falls as rain, it travels through the soil and underlying rocks. By the time water reaches the reservoirs that lie deep underground, it's no longer pure. As rain falls through the air and soaks into the soil, it picks up small amounts of a gas called carbon dioxide. And as this gas dissolves in water, it creates acids that have a great effect on rocks that lie below the soil, especially limestone. The acids will slowly dissolve the limestone as they flow through, creating caverns such as these that can reach for many kilometers. But even as a cave is formed, water continues to seep down from above. The dripping water leaves dissolved minerals behind as crystals of limestone. Little by little, these crystals can add up to build very interesting shapes, such as stalactites that reach down from the ceiling, or stalagmites that reach up from the floor of the cavern. So if you ever get a chance to explore one of these natural underground wonders, keep in mind how they were created over many millions of years and how they're still forming, one drip at a time.
So, in reviewing my memory banks, I see we've got the Earth's fresh water in several forms: frozen water, water in rivers and lakes, and groundwater. And even though it's only a small part of all the water on Earth, it still seems like a lot.
It is, if people use it wisely.
What do you mean? Since water is recycled all the time, how could people use it unwisely?
Well, as you've seen, people can use too much underground water and empty the water table. If they live in an area that gets very little precipitation and has no rivers, then they're out of water. But there can be another problem that can exist in areas with plenty of water. It's water pollution.
You mean dirty water?
It's more than that, Iggy. Many things can pollute water, and some of them can be very harmful to plants, animals, and people. Oil can run off the streets into fresh water supplies above and underground and later into the ocean. Oil can also be spilled at sea. Sprays that farmers use to protect their crops from insects can also get into these waters where they can harm fish and other living things.
Yipes! So the Earth's water is being ruined?
Well, people are learning all the time how to better protect their water from pollution and how to clean up water if it does get polluted. So, Iggy, your memory banks must be full of water now, so to speak.
I sure have stored a lot of information. I've learned that water is very important to animals and plants and is recycled through evaporation, condensation, and precipitation. I know that most of the Earth's water is salt water and that most of the remaining fresh water is frozen in ice or underground. The rest is water found in rivers and streams or water found in lakes and ponds.
And now I have to ask, have you learned to appreciate water?
Yup, just like you said, it's amazing and powerful, and it's renewed all the time. Why, if I weren't a computer, I think I'd want a drink of water right now. But in the meantime, I'll settle for some cover.